Good evening, parents. Mrs. P here again, and I'm going to do a quick video tonight about things that we will be talking about in class next week with your students as we finish Chapter 4, our second unit with the Missouri State Standards, which talk about ratios and proportions. The last thing we're going to discuss before we take our test next week is how we use equivalent ratios when we're graphing. Now, we've learned all kinds of things this week about how do you get an equivalent ratio? How do you take a rate and break it down to a unit rate? Now we want to take those numbers, those solutions we get from equivalency, and plug them into a graph. So I have a really quick problem here for us tonight, and then your students and I will talk more about it coming on Monday with no snow. I'll be following my meteorologist, Western One News reporter Coy Taylor, for the updated information, which means I want no snow. So here's the problem we're going to do tonight about equivalent ratios and graphing. So Coy's 2010 Toyota Camry gets 22 miles per gallon. And I want to know, using the table below, how many miles would Coy's Camry go on 6 gallons of gasoline? Well, I'm first going to ask myself, what do I know about Coy's car? Where Coy's Toyota goes 22 miles per gallon. So I have a table here, and the information I know is that Coy's car goes 22 miles in 1 gallon of gas. But I want to know how far Coy's car would go in 6 gallons of gas. How many miles would it go in 6 gallons of gas? This is using the same concept of finding equivalent ratios. So I could come over here and simply go 22 to 1. I want to find out how far Coy's car goes in 6 gallons. Well, the students know that is multiplied by 6. I must do the same to the top that I did to the bottom. So I would come up and I would multiply 22 times 6. But what we're going to use today is a table so that we can find ordered pairs, that is 2 numbers, known as X and Y, so that we can use those on a coordinate plane, so that we can graph them, and then that way it tells us a little bit more about Coy's car. So I'm going to start ordering these out in our table by using equivalent ratios. So Coy's car is a 1 to 2. Now, of course, then the next number I'm going to fill in my table looks like it would be a 2. How would I get to that? And you know, Mrs. P, I got a bad issue if I wrote the 2 that way. So 2. Well, how would I get from 1 to 2 in our equivalent ratio process, multiplication or division? I would multiply it by 2. Did I do the same up here at the top? I did. And then my next number is 3. How did I get to it? 1 times 3 is 3. What would be my next number then here if I'm going 22 to 3? It would be 66. I go to 4. My next number here would be 88. My next number in the table would be 5. 2 here was 88. So 22 more would be 110. I get to 6. And 1 times 6 is 6. So then here is 22 times 6, which is 100. Oops, I'm supposed to be writing in here. 132. And then I just added a little extra on there, 7. So 22 times 7 then is 154. Now I know a lot more about Coy's car. I definitely know here how many miles Coy goes on 6 gallons of gas. But if I want to relate Coy's car in any other way and show someone more about his gas mileage, then I'll want to fill out the table to create a few more extra equivalent ratios so that I could give someone more data and information on Coy's car. And it would be the same if I did over here an equivalent ratio, because 22 times 6 is 12. Carry my 1, that's 132, and that is what I received. Well, every time I did this, I input a gallon of gas, and I output, that means what do I get once I insert the gallons of gas? I get an output of how many miles. So if 1 gallon goes in, 22 miles is going to come out of the car. 2 gallons in, 44 miles comes out. That's input-output using equivalent ratios. And I can now graph these on a coordinate plane. This is the coordinate grid that your students use in 6th grade. We call it quadrant 1 because positive numbers go in there, offset by parentheses, separated by a comma. And you have to have a thing known as an ordered pair to go in there. You need an X and a Y, an input and an output. I usually use a little input-output man for the kids. I use arms and I say, what's going on in here? If you input 1 gallon and something goes on here, what comes out? 22 miles. So that's what we've done in this table. And I can now grid these by using input, output, X and Y. So my first ordered pair is parentheses 1, comma, 22. Then I have parentheses 2, comma, 44. 3, parentheses 66, and so on and so on and so on. And every time I create one of those ordered pairs, I then can graph it on my grid. This is my coordinate grid. I have broke up my grid by an X and a Y axis. On my Y axis, I have put intervals of 1 for the gallons of gas, and I have put intervals of 10 on my Y axis, which says my miles, and I forgot to write that here. Miles. You can do this on a coordinate plane. You just have to make sure that every time you make an axis, that the intervals, that's what we call these, the separation, the number distance on a grid, are the same. On this X, 1 separates each one. On this one, 10 separates each one. So this coordinate grid will place your ordered pairs on there correctly. So I'm going to go with 1 and 22. But if you notice I don't have a 22, and I tell kids, I'm not asking to be NASA rocket scientist. You see 20, you see 30. You know somewhere right about here is 25. So as long as you place your plotted point somewhere between that 20 and that 25 range. So I'm at 1 and give or take 22. That's the first one. And I can write that on there. I can go 1, 22. And then I'm going to plot the rest of them. 2 to 44 is somewhere maybe in there. Maybe a little bit too far, but that'll be all right. I can then go 3 to 66, a little bit higher. I can then go to 4 and 88, a little bit higher. I can go to 5 and 110, which I actually have a 110. I can then go to 6 and 132. And finally, I can go to 7 and 154, give or take, in there. And eventually, they're going to go on to learn what kind of graphs these are creating, whether they're linear or non-linear equations in algebra, if they make straight lines or if they make curved lines. All we're learning right now in 6th grade is, how can I generate equivalent ratios for a circumstance and then take my input and my output, create an ordered pair for those, and plot those on a coordinate plane with positive numbers in quadrant 1, and eventually do positives and negative numbers from a table with my inputs and outputs. And that's what we're going to be discussing and going on with on Monday. Then we'll start reviewing, hopefully getting in that test on that next week when we are back without any snow. We can hope. Anyway, thank you all for your time. I hope you have a wonderful weekend, and I'll see you back on Monday.